In this video, we are going to enhance our renderer staff by adding a background texture to the staff itself.
Okay.
So we're actually going to bring in a texture, and we're going to match it in position and speed so that it appears to be placed directly behind the notes.
And there's a couple of things we're going to take into account here. We need the size of the texture so we make sure it fits the staff appropriately, at least vertically, because really the width of the texture is going to be variable. Well, it could be variable. If you've got a song that's like 3 hours long, you don't want to have a texture that's, 800 million thousand pixels just going on for infinity. If you've got the drum loop from Freebird playing, I don't even want to think about how many gigs that texture would have to be.
Exactly. So what you're saying is we're going to have to handle some interesting scenarios. In order to make the texture storage efficient, what we're going to do is put together a relatively small texture as a tile, and then repeat that tile as many times as necessary to fill the width of the screen.
Gotcha.
That way we can use a texture that's actually smaller than the screen, much less the song, and therefore we can efficiently use it. The only thing that brings into consideration is that the texture must be designed to tile in, I guess it would be X, to tile horizontally.
Horizontally, right. Well, we're going to scale it up vertically. So
Exactly. But as far as the texture being drawn, it needs to be able to butt up to itself as it's tiled.
Well, let's get rolling.
All right. From the very beginning, inside of our content project, if you remember, we have this texture called staff. And inside of our style class, we can look at where this texture is actually coming from. So all the way back over to game, inside of style, we have this field here called staff texture. So really, we've all along had the texture available to us. It's here in the renderer horizontal that we're going to put it into play. Now we're going to give ourselves a couple of fields to better describe the texture. So we're going to jump in right below our title positions inside of the renderer, and we will make a texture 2D field called background texture. And the purpose of this field is to do the same thing we did with note texture, just to give ourselves as concise of a name as possible to address the texture itself. Now we'll move on to one more field, and that is going to be called background width. And once again, just like with the note itself, keep a nice, simple reference to the background width stored in its own integer field. Now let's jump down to the renderer's constructor and initialize both of these fields. Let's take our, first we've got our background texture, and we're simply going to copy the staff texture out of our style class. So we'll grab style.staff texture, and that gets stored into background texture. Now we need to assign our background width. And this is where things get a little bit interesting. In addition to making the background rendering adaptable so that it tiles the texture, we're also going to make it adaptable so that it will stretch or shrink the texture in order to fit onto the staff.
Okay.
That means we don't have to design the texture to fit a specific pixel value, since the size of the staff could easily change if we changed our note values. Since our note graphic drives the size of a track drives the size of the staff. It means the moment we change our note texture, the size of the staff is going to change.
Right.
So we're going to make the rendering code adaptable so that it will stretch the background texture to fit the staff at whatever size it ends up being.
And in the end, the way we're going to do this is we're going to scale up uniformly, but we're going to be matching to the height of the staff.
Exactly. So we know what our background height will be. That's why we're not even storing a background height, is we'll simply use our span height.
To look at it another way, we're going to scale up vertically while maintaining proper aspect ratio for our texture.
Right. We do want to make sure that we don't have any visual stretching when we do the scaling. So to put this into place, what we'll need to do is we'll need to calculate the aspect ratio. And we can do that by taking our span height and dividing that by the background texture's own height. So we've got background texture dot height, and that'll give us a ratio of how high our staff is versus how high the texture itself is. So that way, if the overall staff is larger than the texture, that means we'll have a value of greater than 1. That means we'll actually have to stretch the texture in width as well in order to match our aspect ratio.
Right.
And vice versa, if span height is smaller than the texture, we'll end up with a value that's less than 1. So we're going to take this ratio and we're going to multiply the background texture's width against it. So we'll look at background texture dot width and multiply it against our ratio value, and then store that new width inside of background width. So that means background width is not necessarily going to be our texture's width. It's going to be a new width based on the height and aspect ratio of the texture.
Okay.
So, moving on from here, actually before I jump away, let's drop down a comment as well and say that this is going to be for handling the background.
And you don't need a background height because that'd be the same as span height.
Exactly, since we're going to be stretching it and matching the span height. Now, inside of our draw method, let's jump in here before we actually draw the tracks themselves. Let's put together a couple of local variables. Rather, we'll begin with one local variable to help us keep track of where exactly we should be drawing this texture. We'll make an integer called background x, and we'll set that to be equal to negative scaled cursor. Because, again, scaled cursor, even though it's going to be matching the new time scale, it's still going to be progressing forward. It's going to be increasing over time. And our notes are moving left off of the screen, so that means the x value actually needs to decrement over time. So that's where we will negate the value held in scaled cursor. Now let's drop in some code to draw our background directly at the inverted scaled cursor. Let's grab our sprite batch, tell it to draw. We will be drawing the background texture, and we're going to assemble a new rectangle to draw it, and that will give us the ability to size the texture appropriately. So we'll make a new rectangle, and that rectangle is going to need a position. It'll need an X and a Y. We'll use background X for the X component. We will use span Y for the Y component, since again, in height and in Y we're just simply matching the staff.
Mm-hmm.
Now for our width, we can plug in the background width field, and for height, we can plug in the span height field. So that will take care of our rectangle. Now we're not going to apply any additional color modulation to the texture, so we'll drop in a color of white. Now with this draw column place, we should have a texture appearing on screen, and it should be moving at the same speed as our notes. So let's see exactly where this drops the texture. We'll jump in and build and run the game, and then we'll jump into the game screen. We can see that we do have a texture.
There it goes.
But it slides off screen, never to be seen again.
Yeah.
It also slides off the screen rather fast because of the tempo of our song.
Right.
So I'm actually going to slow this tempo way down to make it easier to see. Inside of a beat generator, we're assigning a tempo of 100. I'm going to bring that all the way down to 30.
That's a slow song.
So now we should have a much slower progression of notes.
That's like, what, a beat every 2 seconds?
Yeah, that would be, very slow. But watching this now, we have a lot more time to watch the texture go off screen. We can note that as far as motion is concerned, it seems to be matching the speed of the notes properly. We just need to come up with a better way of offsetting it so that it matches the positioning of the song.
Mm-hmm.
Because, of course, we've got a set of lead-in that happens before our notes actually appear. And we need to have more of these textures. We need to set up a scenario where we can repeat the texture in order to get our tiling behavior.
Right.
So let's move into the first topic, which is lead-in compensation. We need to take into account exactly how many ticks it is before the song actually starts. So we'll jump in here right after we make our background X variable, and we'll make a new variable. As a matter of fact, let's jump in before background X.
Okay.
We'll make a local integer called lead-in width. And we'll set that to be equal to the overall, as basically we need to calculate the width span of the lead-in block appropriately scaled into pixels, because ticks no longer translate directly into pixels with the timescale value. So the first thing we need to do is take our lead-in value, which is given in song.leadInBeats, and convert that to ticks.
So we multiply that by ticks per beat.
Exactly. So we can take this and multiply by song.ticks per beat, Now this gives us a number that would correlate to the number of ticks, but again, ticks don't correlate directly to pixels. We need to multiply against one more value, and that is time scale. So that will get our ticks scaled into an actual pixel value, which we will store into lead-in width. Now again, we have to take into account that this operation becomes floating point because of time scale. So we'll put the whole thing in parentheses, and then cast that over to int before storing it.
Okay.
Drop in our terminator, and everything should be happy. Now we can turn around and address our scaled cursor and apply an additional offset. We can offset by subtracting lead-in width. Now let's run the game and see where this has our background texture.
It starts right at the edge of the screen.
Now we can see that, yes, we're starting at the very edge of the screen, which correlates to the notes themselves. Since the notes are starting centered because of screen center, here we're not taking screen center into account, so originally we should have been starting on the very left of the screen, except for the fact that notes have a lead-in value.
Right.
So watching this value that happens right when we jump into the song, this spacing between our hit line and the notes, we had the same kind of spacing happening with our texture. So we need to figure out what that spacing was in terms of an exact pixel value.
Compensate for it.
Exactly, and that places our texture directly on the left edge of the screen. So that's working well, our positioning offset, but we still have the problem of the texture sliding off screen and disappearing forever. Now in order to make the texture stay on screen, we're simply going to have the texture repeat every time it goes past a distance equal to its own width. We can do that by taking background x, and saying that that will be equal to the result of background x modulus background width. So that way the moment it goes one width worth off screen, it should repeat and redraw itself. So now if we run, we should get a repeating texture. As soon as it fades off screen, it immediately clicks back into place on screen.
Gotcha.
So of course, now we need to have multiple copies of this texture drawn to fill out the screen. So in order to do that, we'll put together a while loop, and we'll say that instead of only drawing the texture once, we will continue to draw the texture until we have gone off the right-hand side of the screen. So we'll drop in a while loop. I'll say while background x is less than global state dot fixed drawing width. So as long as we're still within the screen, we'll draw the texture out. Now every time we draw the texture, we need to make sure that we advance background x so that we continue drawing one place to the right of the last texture drawn. So we'll take background x and increment that by background width. So now if we run the game, there, we nicely have our texture filling the whole screen, and because the texture is repeating, every time its own width falls off the screen, it's actually repeating at the same point at which the texture itself repeats as it tiles.
Yeah. So what we have is it's kind of like 5 or 6 copies of the texture that all slide one unit to the left and then disappear, but as soon as they disappear, another one appears right behind it.
Exactly. You could almost say, an analogy you had made earlier was imagining an assembly line where boxes are falling onto the assembly line on one end and falling off the other. So we're having textures that appear over here on the right and then disappear after they go off the screen on the left. So this keeps the drawing efficient. Like you said, where you have a case with a very long song, we're not actually drawing this texture for the width of the song, we're only drawing it for the width of the screen.
Right.
So with that, we now have our staff background drawing, and it is moving appropriately, repeating appropriately, so that takes care of staff background drawing.
Okay.